Okay, so we're going to work on pod work. Again, if you already did the problem, don't worry about it. You can go through that. Okay, so the concept is 6 plus 2 is 8. So that we would be 8 cube root of 5. So that doesn't change. Okay, let's do the other one that we did with addition. Let's try this one. So 2 square root, 2 times the square root of x plus 7 times the square root of x. So we have altogether 9 square roots of x's. These don't change. We also want to make sure that you have the same powers. And so that would be 9 square root of x. Okay. So now to multiplication. So the 4th root of 2 times the 4th root of 8. So outside you can multiply. So 1 times 1 would be 1. And 2 times 8 would be 16. Now, the square root of, or the 4th root of 16 on your power table is 2. So I cross out the 4th root of 16 and I put a 2, and then I multiply everybody outside. Well, that was a 1 there, so 2 times 1 is 2. Feel free to stop this at any time. All right, in this case, again, we have multiplication, so outside to outside. So you want to go 2 times 4, which is 8. Those are both cube roots. And what is 7 times 49? Well, that's 343. And I'm going to double check on my power table that the cube root of 343 is actually 7. So I'm going to cross this out, put a 7, which is out of the radical. And then those that are outside of jail can be multiplied. 8 times 7 is 56. Okay, so what do you do with subtraction, but yet the two numbers underneath the radical are not alike? Well, let's see. Can I do anything with the square root of 5? I can't. Can I do something with the square root of 45? So I'm really working on my simplifying tricks that I'm looking at here. So let's see, square root of 45. Let's find 45 on a square root table. Oh, it's not on there. So let's think, can I find factors of 45? Let's see. Does 36 go into 45? No. 25? No. 16? No. Does 9 go into 45? Oh, it does. 9 goes into 45. So the square root of 45 can be broken down into the square root of 9 and the square root of 5. And the square root of 5 can't be done, but what about the square root of 9? You're right, that's 3. So the square root of 45 can actually be simplified into 3 square root of 5. Now, there you go. So what is 5 square root of 5 minus 3 square root of 5? Well, that would be 2 square root of 5. Okay, so you can't simplify if they're not the same. All right, try another one like that. Okay, in this case, they're square roots. That's okay if it was cube roots. Okay. All right, so let's take a look at this one. Square root of 27. Square root of 27. There is no square root of 27. Let's see. 25, no. 16 going to 27, no. 9, yes. Okay, so notice I'm going to leave this 2. So the square root of 9 times the square root of 3 gives me 27. And the square root of 9 is 3. Now, Remember our rule. Everybody who is outside can be multiplied. So who's outside? Well, 3 is outside and 2 is outside. So what's 3 times 2? 6. And the square root of 3 has to stay inside. So there's that one simplified. Okay, now I have to deal with the 48. 48. Let's see. Well, does 36 go into 48? No. 25? No. How about 16? Yes. We practiced that. Square root of 16. And 16 times 3 gives me 48. Square root of 16, well, that's easy. That comes out. That's 4. But the square root of 3, sad face. You got to stay inside. All right. Now, who's all outside? 4 is on the outside, and so is 3. So what's 3 times 4? Well, 3 times 4 is 12, but the square root of 3 has to stay in. And notice there's a big minus in between, isn't there? Here, I'll put my eraser. Minus, okay? So what is 6 square root of 3 minus 12 square root of 3? Well, that's easy. That's negative 6 square root of 3, okay? Negative 6 square root of 3. I know it's hard to see there. All right, let's continue. Let's do a, there was some simplifying ones that we worked on in class. Okay, but let's work on some rationalizing. Let's do division first. All right, so this would be the square root of fourth root of 192 over 6. Okay, the first thing I'm going to check, okay, is can I divide those? Is 192 divisible by 6? Oh, it is. It can be reduced or divided, so it gets 32. So that's the first thing I'm going to do. So the fourth root of 192 over the fourth root of 6, when you divide it, you get 32. And now take it from there. How do I simplify 32? Well, let's look at the fourth. Let's look at the fourth. So 32. Wow, my only choices are 16. Does 16 go into 32? Actually, it does. In fact, 16, fourth root, and the fourth root of 2. Now, the fourth root of 16, that's easy. That's 2. 2 comes out, but the 2 has to stay in. So my answer here is 2 fourth root of 2. All right, let's try this one. First thing you should check, is 32 divisible by 2? Well, it is. We just did that, right? So what do you get? 32 divided by 2 is 16. Well, that's easy. Is there a fourth root of 16? There is. It's 2. And you're done. Okay? So one of the last pieces really looking at is rationalizing the denominator. Okay? Rationalizing the denominator. So in rationalizing the denominator, we're going to look at, I'm going to give you a different one than what I had originally. So we're going to do the cube root of 3. Okay, so in rationalizing the denominator, the number one thing is that we can't have a cube root at the bottom. Okay, I can't have any root at the bottom. So I need to multiply it by something. So you need to have your power table, because I need to multiply by this 3 and give me something on the power table, and go small. So does 3 times something give me 8? No. How about 3 times something give me 27? Oh yeah, 3 times 9 would give me the cube root of 27, which is 3. Okay. The rule is you can't have radicals in the denominator. So this is called rationalizing the denominator. Okay, notice I did the bottom all the way across. So one of the easiest things I can do is what I do on the bottom, I do to the top. So I multiply by the cube root of 9 and the cube root of 9. And friends, I can't simplify that, can I? I can totally not do that. Okay, that doesn't work. Okay, now you try. The 5th root of 5 over the 5th root of 27. So that's a little bit harder. 5th root of 27. Wow, we've got to find 27 times something to get you something on the 5th root table. So let's turn this over. Let's take a look for a second. Can you see that all right? If I multiply by 9, 9 times 27 gives me 243. So how do I find that? You just see which number is divisible by 27. So if I multiply by 9, here I get the 5th root of 243, which is 3. What I do to the bottom, I do to the top. And I can use my rules about multiplying inside the radicals. And that's how I get 45. All right, last one. 11 over the 4th root of 11. So we're looking for what can I multiply 11 by to get something on the 4th root table. So I'm going to kind of move this off to the side. Is any of these numbers divisible by 11? Okay, yeah, I don't know. Well, let's see. No, that one's a doozy. So this one took a little bit more time to work on, but I wanted to show you this one because there's also 2 ways that you could go back and do it rationalized. If you take this, so that took us all the way down to here on the power table. I'm not planning on doing that to you, but that's one way that you could have done it. So I'm going to leave that view up for you for a little bit. Okay, thanks.